Question number 28 is let x1 x2 xn let x1 x2 xn be random sample from population having PD of this fx uh, involving parameter theta and sigma is 1 by sigma e raised to the power minus x minus theta upon sigma when x is more than theta, 0 otherwise. The question is find the method of moments and maximum likelihood estimator of theta and sigma. Okay, so let's find first method of moment. So for the method of moment, the other tab, yes. So this is the PDF given for random variable x size. So for the method of moment, what we do, uh, it's a population mean is equal to sample mean. So we have to use that. Okay, so see, if I name x minus theta as y, then we can simply see that this function has like if I write in terms of y, fy, it will be 1 by sigma e raised to the power minus y upon sigma. So that is exponential random variable with mean sigma. So if I say mean of y here is sigma. So mean of y is sigma, y what I assumed, e of x minus theta, which is sigma. So from here I will get e of x minus theta, which is sigma, because theta is parameter. So theta is not a random variable. So ex from here we get theta plus sigma. Okay. So from here we got theta plus sigma is equal to x bar. Okay, this is the first relation. And now for more second moment of population is equal to second moment of sample. So it's a method of moment. So so first moment of population is equal to first moment of sample, then second moment of population is equal to second moment of sample. Now I need to find ex square now. So from here what I said, when I say y is equal to x minus theta, so y is exponential, and exponential has mean sigma and variance sigma square. So from here I can say variance of y is nothing but sigma square. So variance of y means what? So y is x minus theta. This is sigma square. So variance of x we get is sigma square, because variance of x plus variance of theta. Theta is parameter, not random variable. So variance will be 0. So variance x is what? Ex square minus ex whole square. This is sigma square, and ex we already have this. So ex square we get theta plus sigma whole square plus sigma square. Theta plus sigma whole square plus sigma square. This is ex square. So from here we got ex square. We can simplify further. So now we have here theta plus sigma whole square plus sigma square is equal to 1 by n summation xi square. And from the first one, theta plus sigma is x bar. So x bar square plus sigma square is equal to 1 by n summation xi square. So from here sigma square we get, so sigma square is 1 by n summation xi square I from 1 to n minus x bar square. So sigma we got is square root of this 1 by n summation xi square I from 1 to n minus x bar square. So this we have, this is the method of moment estimator of method of moment estimator of sigma. So we can write it sigma cap. Now we need to find theta cap. So since theta plus sigma was x bar, correct? So theta is x bar and theta cap, if I write, is a sigma cap, estimator of sigma. So x bar minus the whole square root 1 by n summation xi square I from 1 to n minus x bar square. So this is the estimate method of moment estimator of, so method of moment estimator of theta, correct? So we got this answer. Now we need to find maximum likelihood estimator also. So now we have to find maximum likelihood estimator. So the first question was, this is the method of moment of sigma and this is method of moment of theta. Now come to maximum likelihood estimator. So for the maximum likelihood estimator, we can see here. So fx involving theta and sigma parameter is 1 by sigma e raised to power minus x minus theta upon sigma. So when this hold, when x is more than theta. So if I define likelihood function, it's a product of fxi, this product fxi involving the x1 x2 xn, like we can say x1 x2 xn involving sigma and theta I from 1 to n. So this will hold when xi will be more than theta. So L theta is product I from 1 to n. It's a 1 by sigma e raised to power minus x minus theta upon sigma when theta is less than equal to xi's, less than xi's. So L theta, if we simplify, we get 1 by sigma raised to power n e raised to power minus 1 by sigma summation xi. So this must be xi, summation xi's minus n theta, because summation got over, theta theta n time, so n theta when theta is less than equal to xi. So means what? Theta is less than each xi. So this implies theta is less than minimum of all xi's. Minimum of all xi, I from 1 to 3 up to n. Theta is less than each xi for all I, then will be less than minimum of all. So minimum of all means we can write theta is less than, this is a first order statistics, means theta belongs to minus infinity to x1, minus infinity to x1. Theta belongs to minus infinity to x1. This is the range for theta because we have a function for theta. So now what do? We find derivative of L function, likelihood function. So with respect to theta, so 1 upon sigma n will be as it is, e raised to the power minus 1 by sigma summation xi minus n theta as it is into, so if you so a derivative of e raised to power something, e raised to power something, then derivative of the power. So when we read derivative of power, it's into 1 upon minus 1 upon sigma into minus theta. So at last what we get? We get L dash theta as something like sigma raised to power n e raised to power minus 1 by sigma summation xi minus n theta into theta by sigma. So this is positive because you don't see negative sign, all sigma and theta are positive. Correct? So means what? This is increasing function for theta. Sigma is a fixed constant, so this is increasing function. So L theta is increasing function on interval minus infinity to x1, minus infinity to x1. So minus infinity to x1. So since it is increasing function, so for the largest value of theta, it will be maximum. So we need a maximum likelihood estimator of theta. So maximum likelihood estimator of theta, let us say theta cap. So this is first order statistics. So this is the maximum likelihood estimator of theta is first order statistics. Now we need maximum likelihood estimator of sigma. So we do same thing for the sigma. So we come to that now. So we had f of x sigma and theta. So that is 1 by sigma e raised to power minus x minus theta upon sigma. Correct, when x is more than theta. Okay, so first let's define likelihood function for sigma. So L sigma. So it's a product, same definition, I from 1 to n, 1 upon sigma e raised to power minus x minus theta upon sigma. So it's xi actually, because the definition is f of xi, x1, x2, xn. 1 to n. So when we open it, so we'll get L of sigma as we get 1 by sigma to power n exi. So it's e raised to power minus summation xi minus n theta on sigma. Now for the take log, okay, so log L sigma. So in this case also we can take log. I have not taken, but we can take, okay, we can take log here in L theta. So let's take log hai na, to just simplify this. So log A into log B. So you will get log 1 upon sigma raised to power n minus log E is, and a log e raised to power x is x. So we'll get some finally summation xi. So 1 by sigma summation xi minus n theta. Okay, so let's apply one more time. So we'll get sigma raised to minus n it is. So minus n log sigma. That's a log L sigma likelihood function, log likelihood function of sigma. Or this is 1 by sigma summation xi minus n theta. Okay, so now what we do, we first differentiate because we need to find sigma such that likelihood function is maximum. So for that we have to find first derivative and put it 0. So let's put it minus n upon sigma. So minus n upon sigma, because log sigma is driven by sigma, minus 1 upon sigma derivative minus 1 upon sigma square. So summation xi minus n theta, I from 1 to n. So let's put it 0. So when we put it 0, or we can find second derivative to check. So let's one time find second derivative. Log L sigma. So 1 upon sigma minus 1 upon sigma square. So n upon sigma square we get. And 1 upon sigma square has derivative minus 2 upon sigma cube. This is as it is, summation xi minus n theta. Okay, so for the maximum likelihood of sigma, so for the maximum or minimum, what we do, we put this is equal to 0. So let's put this is equal to 0. So what was this? It's a minus n upon sigma. So minus n upon sigma plus 1 by sigma square summation xi minus n theta. This is going to be 0. So from here, n upon theta is equal to n upon sigma is equal to 1 upon sigma square summation xi minus n theta. So sigma n is equal to summation xi minus n theta. So we need sigma, right? So sigma is 1 upon n summation xi minus theta. Okay. So since we had the MLE of theta was first order statistics. So MLE of sigma cap will be, this is x bar actually, and this is x1. So maximum likelihood estimator of sigma we get is x bar minus x1. Okay, what is use of second derivative? So if we use this thing, sigma is equal to this, if we put here, so we'll get second derivative as negative. When you put in place of sigma, so we'll get this function negative. So because we need maximum, so for the function to be maximum, second derivative will be negative. So L sigma, likelihood function of sigma is maximum when sigma is this. So x bar minus x1. This is ML of this. So there were 4 questions. Okay. So what we got? Question was method of moment of theta, method of moment of sigma, MLE of theta, and MLE of sigma. So we got all 4. Okay. Yeah. Thank you so much.